In this video, we are going to discuss about that what preparations of ethers by using that what and Williamson synthesis reaction. By using this Williamson synthesis reaction, we are preparing that what symmetrical, unsymmetrical ethers. What is the meaning of symmetrical, unsymmetrical ethers means? The best example for the symmetrical ethers is ROR. This is the symmetrical ethers. Now, dimethyl ether is the symmetrical ether. Diethyl ether is the symmetrical ether. Next, what is meant by an unsymmetrical ethers? It is having the general formula is ROR. To that ethereal oxygen, different alkyl groups are attached means then they are called as unsymmetrical ethers. That is CH3O C2H5. To the oxygen, different alkyl groups are attached means then they are called as what? An unsymmetrical ethers. Next, what is this Williamson synthesis? Whenever this sodium alkoxide reacting with what an alkyl halides, we are going to get that what ethers plus NaX. Now this is the sodium alkoxide. Sodium alkoxide, whenever it is reacting with an alkyl halide, then it is follows an SN2 mechanism, nucleophilic substitution reaction. It is follows SN2 mechanism, then we are going to get the ethers plus NaX. SN2 mechanism. How this alkoxide is going to be what formed? What is meant by alkoxide? Now whenever alcohols, now this is an alcohol. Whenever alcohols are reacting with either NaOH or KOH, then we are going to get what? Alcohols are always releasing that what H plus ions because they are having that what an acidic nature. So therefore we are going to get that what releasing that what H plus ions and forming that what alkoxide ion, and here Na plus elimination of water. Now this is called as what? And sodium alkoxide. Sodium alkoxide. Alcohols are reacting with base, either sodium hydroxide or potassium hydroxide. We are going to get that what? If it is sodium hydroxide means sodium alkoxide is formed. If it is reacting with the potassium hydroxide means we are going to get that what? Potassium alkoxide. This is the preparation of alkoxide, sodium alkoxide. Sodium alkoxide. Next here, what is the conditions of an Williamson synthesis reaction? Here we are using alkyl halide, no? That alkyl halide must be what? Either alkyl halide is more reactive than that what? 1 degree alkyl halide, which is more reactive than 2 degree alkyl halide, which is more reactive than 3 degree alkyl halide. Why this alkyl halide is more reactive than this means? Now when we are moving from this side to this side, steric hindrance increases. Whenever steric hindrance increases, SN2 mechanism is what? Decreases. Okay. So therefore, alkyl halides, so primary alkyl halides is more favorable than 2 degree, 3 degree. Generally 2 degree alkyl halides, so 3 degree alkyl halides, so they will follow elimination reactions. Okay. No? Next, see now which alkyl halide is more favorable. In 1 degree, which is more favorable? Alkyl iodide is more favorable than alkyl bromide. Alkyl bromide is more favorable than alkyl chloride. Alkyl chloride is more favorable than alkyl fluoride. Why alkyl iodide is more favorable means here iodide is the best leaving group than what? Bromide, then chloride, then fluoride. So iodine is the best leaving group. So therefore alkyl iodide is more favorable. Okay. Next, another tip. Now this is called as what? Aryl halides. Generally aryl halides without electron donating group, they won't undergo that what? Substitution reaction. Whenever an electron donating groups are present, then this is undergoing what? Substitution. Aryl halides are undergoing substitution only in the presence of an electron withdrawing group. No electron withdrawing group, there is no nucleophilic substitution because here halogen is attached with what? An sp2 carbon. One reason, that is one reason. Another reason is between halogen and this carbon there is a partial double bond is there. So breaking of partial double bond is difficulty. So therefore here aryl halides do not undergo nucleophilic substitution reactions in the absence of electron withdrawing group. Wherever electron withdrawing group is present, this bond is easily broken. Carbon halogen bond is easily broken. Then the substitution is going to be what happen. Okay, now by using these three simple tips, we can solve that what and Williamson synthesis reactions. Next, how we are going to solve this question? See now here given alkyl halide is Me. Me means methyl bromide. Now this is an alkyl halide. Now this alkyl halide is reacting with what? This alkoxide. Now CH3 for the carbon. How many methyl groups are attached? 3 methyl groups are attached. Now this is O minus Na plus. Okay, now this is called as what? Sodium tertiary butoxide. Sodium tertiary butoxide. This is tertiary carbon. 1, 2, 3. 3 carbons are connected. So tertiary butoxide. Now this is alkyl halide. According to our conditions is what? Now this alkyl halide is more favorable than this one. Okay, now this is alkyl halide. Now this tertiary butoxide is acting as a what? A nucleophile. Okay, now this nucleophile is donating the electrons to this carbon. Now the leaving group is leaving from the front side. SN2 mechanism. SN2 mechanism means nucleophile is always attacking the halogen attached carbon from the rarer side. Then the leaving group is leaving from the front side. So therefore what we are going to get now, this carbon CH3, 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 now O, carbon, oxygen. Now this is attached with this one. Now this Na plus, this Br minus, they are going to be formed as a what? An NaBr. Now this is called as what? An ethers. Unsymmetrical ethers is formed. An unsymmetrical ethers is formed. Next, second question. Now Me means CH3. Now this is CH3ONa. Sodium methoxide. Sodium methoxide. Now whenever it is reacting with what? See now this given alkyl halide is 3 degree alkyl halide. Now given alkyl halide is 3 degree alkyl halide. Because halogen is attached with what? 3 degree carbon. Halogen is attached with a 3 degree carbon means 3 degree alkyl halide. See now here 3 degree alkyl halide is undergoing elimination than that what? Substitution. So therefore here because of steric hindrance, now what will be happen? This sodium methoxide will acting as a what? Base. Now the base abstracting this alpha hydrogen. Whenever the base is abstracting this alpha hydrogen, here what will be happen? Carbon is having the negative charge. Now carbon is having the negative charge means highly unstable. So therefore immediately it is giving the electrons to this one. Then the leaving group is leaving. So then it is follows an E2 mechanism. Because the given alkyl halide is 3 degree. Alkyl halide is 3 degree means elimination is favor than that what? Substitution. Okay, no. So therefore E2 mechanism we are going to get that what? Alkenes. Now what we are going to get the product here? This base abstracting this alpha hydrogen. So therefore what we are going to get? MEOH plus now CH2 double bond, CH2 double bond, CMe. Me means methyl group, CH3 group, plus this Na plus, this Br minus, then they are going to be formed as a what? An NaBr. We are going to get that what? An alkene is the major product. If we have taken that alkyl halide is 3 degree. So 3 degree alkyl halide is not favorable for the formation of that what? Ethers. Okay, now this is the condition number 1. Next here. Now this is sodium phenoxide. Now see, now this halogen is attached with what? 1 degree carbon. So therefore 1 degree alkyl halide. 1 degree alkyl halide is favorable for what? A nucleophilic substitution reaction. So therefore this nucleophile attacking this carbon from the back side, then the leaving group is leaving from the front side, then it is follows an SN2 mechanism. Then what we are going to get? pH. This oxygen is giving the electrons to this carbon, so therefore O. Now CH2, CH3, next this Na plus, this Br minus, they will form as a what? NaBr. They will form as a what? NaBr. Okay, next. Okay, and this is acting as a what? Sodium phenoxide is acting as a what? A nucleophile. While this nucleophile is attacking this carbon, means here halogen is having that what? A negative charge. This carbon is having that what? Positive charge. Now this carbon is electron deficient center, so therefore nucleophile is attacking this carbon. Halogen attached carbon will be attacking by the nucleophile from the rarer side. Next, now this is called as what? Sodium alkoxide. Here this is called as what? An aryl halides. Generally aryl halides do not undergo a nucleophilic substitution reactions in the absence of electron withdrawing group, because the halogen is attached with what? An sp2 carbon. Carbon halogen bond length is less, so strong bond. That too here between halogen and carbon there is a partial double bond, so substitution is not possible in the absence of electron withdrawing group. So therefore here an ethers cannot be what? Formed. No reaction, no nucleophilic substitution reactions is possible, because it is a aryl halide. No electron withdrawing group is present. Already here I given one tip. No, what is the tip? Aryl halides do not undergo nucleophilic substitution reaction, but electron withdrawing groups is present, means they will undergo that what? A nucleophilic substitution reaction. Next, see now here. Now this is the nucleophile. Sodium methoxide is the nucleophile. Here electron withdrawing groups are present. NO2 is the strong electron withdrawing group. Because of this electron withdrawing group, the carbon halogen bond will become what? Weaker bond. So therefore this nucleophile is what? Attacking here. Here carbon electron density will be what? Very less because of this withdrawing group. So nucleophile is attacking this one, then this leaving group is leaving. So therefore we are going to get that what? An alkyl. See now this is alkyl, aryl ethers are going to be what? Formed. Alkyl aryl ethers are formed. See the difference between this reaction and this reaction. Nucleophile is the same, but here alkyl halide is no withdrawing group. Here alkyl halide is withdrawing group. Because of this withdrawing group, here halogen attached carbon is having more electron deficient center. So attacking of nucleophile is easy. Then the leaving group is leaving from the front side. Next, rank the following alkyl halides in the decreasing order of reactivity towards an Williamson synthesis reaction. Which alkyl halide is more favorable towards Williamson synthesis reaction? Now this is 3 degree alkyl halide, not favorable. Now this is an 1 degree alkyl halide. This is 1 degree alkyl halide. Okay, now next this is also 1 degree alkyl halide. Next this is also 1 degree alkyl halide. Why it is called as 1 degree? Means this carbon attached to this carbon, so therefore it is 1 degree carbon. Halogen is attached to this carbon connected to this carbon, so therefore it is 1 degree carbon. Now halogen is attached to 1 degree carbon, so therefore it is called as 1 degree alkyl halide. Now this is 1 degree, this is 1 degree, this is 1 degree. Now which 1 degree alkyl halide is more favorable? Now here chlorine, bromine, which alkyl halide is more favorable? Alkyl bromide is more favorable than alkyl chloride. So compare these two. Now this is called as what? Allyl. This carbon is called as what? An allyl carbon. What is meant by an allyl carbon? Now this is a double bonded carbon. Now double bonded carbon connected carbon, if it is sp3 carbon, then it is called as what? An allyl carbon. Now this is called as what? An allyl carbon. To this carbon, halogen is attached, no? So therefore it is called as an allyl halide. This is called as an allyl halide because allyl carbon. Now generally in SN2 mechanism is transition state. SN2 mechanism is depends upon that what? Stability of transition state. More is the stability of transition state, more is the SN2 mechanism. Here in the case of this alkyl bromide and allyl chloride, allyl is more favorable when compared to that what? Alkyl, because here transition state is more favorable. Transition state is more favorable in the case of allyl when compared to alkyl. So therefore B is more reactive because of allyl. If benzyl is there, benzyl is more reactive because the transition state is stabilized by that what? Resonance. So more is the stability of transition state, more is the SN2. Here allyl is having that what? And resonance. Because of that resonance, the transition state is stabilized. So therefore it is more reactive. Next, compare these two. This is bromide, this is chloride. Bromide is more reactive. Next, this is 3 degree, this is 1 degree. So 1 degree is favorable. This is the rank of towards that what? And Williamson synthesis reaction. Next, in previously they are asking the questions are like this. Williamson synthesis reaction is an example. Williamson synthesis of ether is an example of. This is JEE Mains 14 they are asking. Nucleophilic addition, electrophilic addition, electrophilic substitution, nucleophilic substitution. Yes or no? Williamson synthesis is as a what? A nucleophilic substitution reactions, that it is following an SN2 mechanism. Nucleophilic, what is meant by SN2? Bimolecular nucleophilic substitution reaction. So therefore nucleophilic substitution reaction. Next, allyl phenyl ethers can be prepared by using that what? And Williamson synthesis reaction. We want allyl phenyl ethers. Now what is the answer? Allyl phenyl ethers. So now this is phenyl bromide or aryl bromide, aryl halides. Aryl halides, no electron withdrawing group is present. Aryl halides, no electron withdrawing group is present. C6H5 means this is the ring. Okay, no electron withdrawing groups, no. So therefore nucleophilic substitution reactions cannot be happened. So therefore this is not an answer. Next one is here. Now this is what? Halogen attached to that what? An allyl carbon. Double bonded carbon connected carbon is what? An sp3 carbon, allyl carbon. Halogen is attached, so therefore allyl. Now here this is called as what? Sodium phenoxide. Sodium phenoxide. Now what will be happen? This nucleophile attacking this halogen from the back side, then the leaving group is leaving from the front side. Then we are going to get that what? Allyl. This is allyl, no? This is allyl. Allyl, CH2 double bond CH, CH2. This nucleophile is giving the electrons to this carbon, no? So therefore O C6H5. Now this is allyl, this is phenyl ether. Allyl phenyl ether can be prepared. Okay, now next here we want allyl phenyl ether only, no? So therefore this time. Next, generally this is what? This is called as what? Vinyl bromide. Generally vinyl aryl halides do not undergo an SN2 or SN1 reaction because halogen attached to an sp2 carbon. So therefore generally vinyl halides, allyl halides do not undergo nucleophilic substitution reactions. So no reaction. So therefore answer is B. Next, this is asked in 21. Synthesis of ethyl phenyl ether can be achieved by Williamson synthesis. WS means Williamson synthesis. Ethyl phenyl ether formed by what? Williamson synthesis reaction. Yes, it is possible. See now ethyl means what? C2H5. sodium ethoxide plus phenyl ether. Phenyl ether. Sorry, this is taking means we are not going to get. That means what? This we have to take. This is we are taking as a alkyl halide. Next, phenoxide ion, sodium phenoxide ion we have to take. Because aryl halides do not undergo nucleophilic substitution, no? So therefore it is becoming as a alkoxide, then it will becoming as a what? Alkyl halide. So then we are going to get reaction of bromobenzene with sodium ethoxide yield a ethyl phenyl ether. Bromobenzene. What is the meaning of bromobenzene? Bromobenzene means halogen is attached to benzene ring. In the absence of electron withdrawing groups, aryl halides do not undergo nucleophilic substitution reaction. So therefore, assertion is correct. Reason is incorrect. Reason is incorrect. Okay, because aryl halides in the absence of electron withdrawing group. I given tips. In the tips, aryl halides in the absence of electron withdrawing group cannot undergo nucleophilic substitution reaction because halogen attached to sp2 carbon. Halogen directly attached to the benzene ring means it won't undergo nucleophilic substitution reactions in the absence of electron withdrawing group. Next, these questions are asked in NEET 2016. Now this is a what? Cyclopentanol reacting with NaOH and forms A. A is reacting with alkyl halide, then we are going to get B. Now alcohols are reacting with base, then they are forming as a what? An alkoxide, yes or no, by the elimination of water. Then what is the product A? Now it is called as a what? It is called as a what? And sodium alkoxide. Now this is called as a what? A sodium alkoxide. Now this sodium alkoxide is acting as a what? A nucleophile. Now this is alkyl halide. Halogen is a minus charge. This carbon is the positive charge. So nucleophiles always donating the electrons to an electron deficient center. So now this nucleophile is donating the electrons to this carbon. Then this iodine is leaving from that what? Outside. Then it is follows an SN2 mechanism. Then we are going to get that what? Ethers. Now we are going to get that what? Ether. Unsymmetrical ethers are formed. This is called as Williamson synthesis reaction. Next, here what is given? Tertiary butoxide is given. Already we discussed. Now this is alkyl halide. Halogen minus, carbon plus. So therefore nucleophile is always giving the electrons to an electron deficient center. Then the leaving group is leaving from the front side. Then we are going to get ethers. Okay, thank you. This is overall about an Williamson synthesis reaction.